Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's continue part 3 of chapter 1, voltage amplifier. Okay, what is voltage amplifier? Your input is in voltage. So this will be the sine wave. And your output will be enlarged only in terms of amplitude. So let's say your input is millivolt, your output will be volt. So how you measure the performance of the amplifier is the gain. That is what we call here AV equal out over in. So here become the output voltage is V out and the input voltage is V in. So this is the gain AV. So for voltage amplifier, your gain denoted by AV equal V out over V in. Okay. So how about the equivalent circuit? So we only have 3 elements here inside the dotted line. The first one is the input resistance connected to the input, output resistance connected to the output, and we have one what we call here a source, a dependent sources. So it depends on what? It depends on the gain. So this is the gain and also the input voltage. So we have here is R in, and here is a dependent sources that is depend on the gain of the amplifier multiplied by the input voltage. What does this mean? Means if the input voltage change to other value, so it will depend here, right? So means the value of the voltage source here also will be changed accordingly. So here you have R out. So this is what we call equivalent circuit of a voltage amplifier. Please take note that the gain we don't have any unit because the unit here will be cancelled out. Okay. Let's see one example here. So this is a circuit of a voltage amplifier. So if you recall back Thevenin, what is the equivalent circuit of the Thevenin? So we have here VTH plus minus a voltage source VTH in series or in parallel. So it becomes in series with your RTH, right? So this is what we call equivalent circuit of the Thevenin. So if we look at the voltage amplifier, the circuit at the output will be almost the same with Thevenin, right? Because this voltage will be in series with the resistor. So how can you recall this one? Voltage amplifier always relate to the Thevenin at the output voltage. What will happen at the input? We only have R in. Okay, the question says output voltage of the amplifier is 10.5. So that is V out equal 10.5 volt. Your V in equal 150 millivolt. Determine the voltage gain. So what is the gain here? Gain is equal to V out over V in. So the V out here is 10.5 divided by 150 millivolt, 10.5 volts. So you can cancel the unit and then you can find the gain is equal to 70. So what does this gain means? If your input here is 1 volt, your gain is 70, means your V out will be equal to V in multiplied by gain, right? So it become 1 multiplied by 70. So your amplitude of the output will be enlarged by 70. So that's what the gain means. Okay, so let's go to example 2. So for example 2, we have a voltage amplifier saying a load resistance. So what does that mean by a load resistance? Is a RL here. So your RL here is 475 connected to the output voltage of 10.5 volt, right? And your input is 150 volt. Assume the output resistance is 25 ohm. You need to determine the open circuit voltage gain. So what does that mean by this open circuit voltage gain and open circuit voltage? Okay, why the name given open circuit voltage? Because at this circuit, the output is not connected to the load. So when the output is not connected to the load, you can assume that your V out here will be the same with AV VI. So means your V out here is the same with AV VI. And your open circuit voltage gain. So the gain that mentioned here is this is the gain. This is only open circuit voltage. So if the circuit don't have any load, we can denote that open circuit voltage is equal to AVVI. What is open circuit voltage gain? Open circuit voltage gain is the AV at the output. That is connected to the output voltage here. The AV at the dependent source here. Okay. Well, how about the circuit that is having a load? So this is the circuit that is having the load, means there is additional RL here. So if there is additional RL here, you cannot denote open circuit voltage, means that you cannot denote V out is the same with AVVI. No, because you have a load here. Without the load, you can denote V out is directly equal to AVVI. So what is that output's open circuit voltage gain? The same with what is happening at the dependent source here. So this AV we call open circuit voltage gain. So before you solve the question, check whether the circuit is having a load or not. If there is a load, you can denote. When there is a load, you cannot denote V out equal AVVI because there is a load there. Okay.